Hey guys, welcome back to my channel on the series of binomial theorem. So let's check this out. How many times does a plus b raised to power 6 have? Good. So generally, whenever we have a binomial theorem of a plus b raised to power n, how do we know the number of times this are? Good. We we have a general way of what of getting this to know the number of times these are. So what do we do here? Generally, in binomial theorem we have a full formula that's I is equals to summation of r is equals to 0, r is equals to n, NCR, you have a raised to power n minus r, and b raised to power r. That is a full formula, a formula for what? This is what we call a binomial theorem. It's a theorem is a way of what? Of expressing the terms of what? Of an expansion of a binomial to let's say what? Particular power n. Good. Now, well, do you have to go through this? No, we don't have to go through this. We can know the terms of this without going through this. Good. So now, they're asking us how many times does a plus b raised to power 6 have? Number of times they have. So generally, you don't know this formula. Generally, I want you to know that a plus b raised to power n always have n plus 1 terms. N plus 1 terms. So anytime you have a plus b raised to power n, always have n plus 1 term. So good. And let's go to this answer. So for this answer now, answer for a plus b raised to power 6, how many times? That will be what? It have 7 terms. That is your answer. It have 7 terms. You can see a plus b raised to power 6 have what? Have 7 terms. I'll do an example to show you why this is. But let's check another question. So let me do an example. Example 2. You have a plus b raised to power 2. How many times does it have? How many times does a plus b raised to power 2 have? A plus b raised to power 2 have a particular number of power from the formula. Number of terms will be equals to n plus 1. That will be the number of terms a plus b plus 2 have. Let's take it out. What is here? 2. 2. N is 2 plus 1. That means what? 3 terms. So we have 3 terms in what? 3 individual terms in what? In a plus b raised to power 2. But let's take it out. So we have a plus b raised to power 2, which is what? A plus b times a plus b. Then expanding this, you have what? You have a squared plus what? Plus ab plus b squared. This gives us a squared plus 2ab plus b squared. You can see how many terms? 1 term, 2 terms, and what? And 3 terms. You can see you have 1, 2, 3. You have 3 individual different terms. So 3 individual different terms makes up the what? The power of 2. So you can see that the number of terms is what? Is n plus 1. It's n plus 1 because you can have 1 plus 2 plus 3. Which is what? This. You can see this is what? They are both the same. Let's check out another one. Let's check for this. Answer. My number of terms will be what? N plus 1. What is n? 3. Plus 1. That is what? 4 terms. You can see we have what? We have 4 terms. But let's check it out. So we have a plus b raised to power 3. When you expand this, you have a plus b times a plus b times a plus b When you do these two, you have a squared plus 2ab plus b squared, and this a plus b. When you have this, you have a final answer with what? A raised to power 3 plus 3a squared b plus 3ab squared plus b cubed. So you can see you have a what? You have an a cubed plus 3a squared plus 3ab squared plus b cubed. How many terms? 1, 2, 3, 4. You have 4 different terms in what? In expansion of what? Of raised to power 3. So you can see 1, 2, 3, 4. 4 terms. Not the value of this, not the value of this. Also different terms. 1, 2, 3, 4. You can see it also was equals to what? To this. So anytime you are being asked the number of terms of an expansion, without expanding it, cannot the number of terms by just adding 1 to it, and that makes 4 terms. So let's go to the question. Let's check this out. A question is, let's take a question. Which of the following powers of binomials have an even number of terms? Figure 1, you have 3. Figure 2, you have 6, 8. Figure 3, you have 2. Figure 4, 9. So which of the following powers of binomials have an even number of distinct terms? Give the following answer. So what will be your answer? Number of terms of now they're asking that the number of terms of each power of this, that will be even number. You can see an even number of distinct terms. Even number. Now the number of terms 6 will give. For 6, that will be what? N plus 1. Number of terms n plus 1. What is 6 plus 1? For n6 is what? 6 plus 1, that is what? 7. Is 7 an odd number or even number? An odd number, not an even number. So that is 1. This option is out. Next one, let's check for what? For 8. That will be what? 8 plus 1, that is 9. Out. It's not an, it's an what? An odd number. Odd number. Can you see that? Whenever you have an expansion raised to power 6, and it's like, let's say like a plus b raised to power 6, it will give 7 terms. A plus b raised to power 8 will give 9 terms. Are you getting me now? 9 terms. 9 terms, 7 terms. What about this? For this, n2 will give you 2 plus 1, and that is what? 3 terms. Also an what? An odd number. Let's check for 9. For 9, that means the number of terms for powers of 9 will be 9 plus 1, and that is 10 terms. You can see that is what? That's the correct answer. This will be our correct answer because it was, it gives 10 an even number of distinct terms. So that is what? As an even number. So generally, let me tell you the point generally. Generally, every powers of an even number will give an odd number of terms. Are you getting? Why an odd number and a power that is an odd number will give an even number of terms. So you can see how it goes and they are opposite each other. So whenever you have a power of an even number, you get an odd number of terms. While if you have an odd number, while you have an odd power, a power or it is an odd number, it gives you an even number of terms. And before I can go, I would like you guys to subscribe to my channel and like my videos. Thank you.